We can start. We have like 80 people on the webinar. I will go with a short introduction regarding the ZEVinnovation project, and after me, two presentations will follow. After each presentation, we will have like a session of very quick questions, one or two, and at the end of the second presentation, you can ask more questions, but also during the presentation you can ask questions, and we will then I will ask our presenters. So once more, hello to everyone. My name is Boris Josic. I'm coming from a Center of Technology Transfer, Croatia. We are lead partner of ZEVinnovation project. ZEVinnovation is the short name of the Strengthening Transnational Cooperation, Knowledge and Technology Transfer in Development of Electric Vessels and Fostering Innovation in SMEs. So title of our plenary session is Exploring Application of Zero-Emission Vessels in Maritime. As a short introduction, I will look about the project and program, about project partners, about CTT, about the plenary session lectures, short review of battery technology, and at the end we will present our presenters. So about the project and the program. The ZEVinnovation project is funded by Iceland, Liechtenstein, and Norway through the EA and Norway Grants Fund for regional cooperation. Total project budget is 1.6 million euros. The main priority of the fund was innovation, research, education, and competitiveness. So we are trying to connect everything in our project. We are looking for the innovation. We are trying to connect research and SMEs. And also to educate, to have different webinars, to participate on different conferences, to share the knowledge about zero-emission vessels and about electric, hydrogen, and fuels beyond the hydrogen. Program fund regional, cross-border, and transnational cooperation, because fund see that this is the very important, and it's the easiest way to reach a solution of zero-emission vessels. Because of that, we have partners from Croatia, Poland, and Norway in order to share the knowledge and in order to transfer the knowledge. In total, over 700 applications, 20 projects were selected, and one lead partner from Croatia, CTT, in this case for the ZEVinnovation project. Project duration is 43 months. We are starting now. We spent the first 6 months in the researching the sector, connecting with the stakeholders, and now in this year we will have a series of webinars in order to present in more details topics, and to see how to help different stakeholders and how to connect different stakeholders. As I said, we had the partners from 3 countries, and in total 5 partners participating in the project. So lead partner is the Center of Technology Transfer from Croatia. We have 3 beneficiary partners, Croatia, from Croatia 2, from Poland 1, Baltic Sea and Space Cluster, and we have 2 expertise partners who are actually transferring knowledge from Norway to Croatia and Poland. Because of that, we always have on our workshops presenters from Norway in order to share knowledge in this sector, because they are ahead of other countries in the zero-emission vessels. So we have expertise partner OKP, experts in the technology, and the Vinco Innovation, expert in the innovation. So short introduction to CTT, founded in '96 by the University of Zagreb, Faculty of Mechanical Engineering and Naval Architecture. So we are 100% owned by the faculty. What are strategic purpose of this Center of Technology Transfers? To connect science and economy. So our idea is to connect companies with researchers on the faculty and help them in the funding the projects, in the writing the projects, in the developing new projects. to enhance the competitiveness of Croatian industry by helping to connect with the researchers. We want to strengthen the role of University of Zagreb, Faculty of Mechanical Engineering in this process. And we are Center for Innovation and Technology Transfer. We are helping stakeholders and the researchers in the field of innovation and technology transfer. So what are our main activities? Are transfer of knowledge into economy through the different projects. And we also lifelong learning. We have a lot of seminars, webinars where presenters and organizers are professors from the faculty, and attendees on these seminars are coming from SMEs. We also have incubation and acceleration of SMEs, of entrepreneur ideas. So we have incubator for startup and spin-offs, and we also have the student incubator. What is the project aim and the potential of the project? So everything is playing with zero emission vessels. So, and we are trying to connect companies, connect research organization, and everything we want to happen through this our innovation hub, which is the main field of our project, place where we will have the possibility to connect, share, and work together between different stakeholders. So, as I said, this is the establishment of efficient and sustainable network, involvement of multidisciplinary partners, researchers, SMEs, and from different sectors, working on collaboration, supporting market uptake of ZEVs, and we are offering tailored expertise to selected companies. We want to help them to commercialize their ideas. And we want to work together for application for the new projects. And as a short introduction to this webinar today, I will present some results from our last paper regarding the electric batteries, using batteries in electric ferry boats. So we analyzed 3 routes in Croatia with 1.6 nautical miles, 8 nautical miles, and 30 nautical miles, ship 1, 2, and 3, connecting different islands in Croatia. So we analyzed the existing system compared with 3 different technology of batteries: lead acid, nickel, and lithium ion batteries. We analyzed life cycle assessment and life cycle cost assessment. We used European electric mix, so it's on the European level. If you go for the national, of course, there is no problem. So our idea was to see how much everything costs, what is the influence, and if we look regarding the different ship, different routes. So if you look results, CO2 emissions, of course, batteries reducing. You don't have emission from the operating of the ship, but you have a lot of emission in the production because we use European mix. If you go to 100% of renewable electricity, these emissions of CO2 probably will be reduced. This is the result of the analysis for ship 1, 2, and 3. As you can see, SOX nickel batteries have a lot of SOX because of the manufacturing process. The most important thing is also LCCA comparison. So you can see ship 1, 2, and 3 operation costs are lower, but here we're facing the problem of the size of the batteries. So it's like 8 megawatt hours of the size of the batteries in the ship number 3. So this is actual comparison between short and long ships, what is happening when you analyze the system. So, and because of that, our next presentation will cover first part is with electric ships, typically used for the shorter destination, and Anders will present after batteries and hydrogen, how to work and how to design your system, what are other options beside of batteries and hydrogen. So this is for me for the introduction. Our next presenter will be Tomislav Uroda from iCat company. So Tomo, floor is yours. I will stop sharing. So I think you can start now for with your presentation.
Good morning, everyone. I hope you can see my screen and you can hear me well. We had some technical issues before. My name is Tomislav Uroda. I'm coming from the iCat company. iCat stands for Island Catamaran, and this is it was startup company some 10-15 years ago. If we take a look of the main idea why we have started the company, that was the challenge from the Croatian market, and that is 1,000 island without efficient transportation network. I'm saying that one because I believe the market potential is very important for the R&D activities. So if you are developing any kind of innovation, you have to see clear market for that kind of innovation. Regarding the electric vessels and the zero-emission vessels, and that is something which is happening now. A bit before it was in Norway, and now it's coming on the other countries in the world. As I told you, we have started some 15 years ago. It was just the basic idea how to connect the islands. And then we realized that we have, as a small company, we have to set up the partnership with R&D institutions, and that was the University of Zagreb, and later on Končar Institute. Končar is Electrotechnical Institute in Croatia, and we have been dealing with Končar Institute in development of electrical propulsion on the vessels. At the beginning, it was very challenging regarding the battery technology. The example, the picture on the right down corner of the screen, you will see the land plot of the Šibenik area, and this is the city which have asked us to develop new system of transportation. And they said, yes, we would like to have it with electric vessels. This is the market, and this is the market requirement for whom you can develop something like that. At that point, we have been developing that with lithium batteries, lithium iron batteries, and for the fast vessels, it was not feasible at the moment. In the second part of our short history, we have been dealing with several EU projects, and we have finished all of them at the moment. We have set up our own production, and we have built 4 solar-powered vessels. On the picture, you can see production and the one of the vessels. The first one, SolarCat. This is the 3rd generation of the solar vessels we are building. The first 3 vessels have been built for National Park of Mljet in Croatia, and they have been 1st and the 2nd generation. This is then the experience from the shipbuilding, where you can see that you can improve some parts of the systems. Very similar, like in any other segment of production. If you take a look of the car industry, over the 100 years, there have been significant improvement of the engines with regards to the speed. That's mostly the speed of the cars, and sometimes it would be needed then for improving the vessels as well. This small vessel is the Catamaran, 15-meter length, 5-meter wide, and it has small engines, 2 times 12 kilowatts. We can upgrade that one to the high power, but the basic idea here was to have self-sustainable vessel. That means with those small engines, with optimized hull resistance and the weight of the vessels, we have the cruise speed 5 to 6 knots and maximum speed almost 10 knots. On the screen here, you will see some data about this vessel. The name of that one was Baby Cat. Solar Cat is the third generation, which follows the Baby Cat vessel, as I told you before. And on the screen, you can see deliveries of new building number 2 and number 3. New building number 2 was delivered in summer 2019, and we have been sailing from Split to Mljet. This is the distance of 75 nautical miles. We were sailing 13.5 hours with average speed 5.5 knots. And the batteries at the arrival remained at 50 to 60%. Then we have midwinter delivery. That was the early January 2020. Same speed, not the same distance. The distance was 62 nautical miles. 11.5 hours of sailing. That means sailing without stopping. And then we have drained the batteries almost completely, some 90%. The Solar Cat, which is the next generation of that vessel, has 30% more power in the batteries and 20% in the solar panels. Emphasizing on those vessels is the solar energy. So they are sailing in a national park for some years already, and they never recharge them. The only energy they need, they got it from the sun. This is the second concept of the vessel we have designed, and that would be the next one for us. This is the fast electric ferry. That means we are not using the solar energy here because the roof space is pretty small with regards to the amount of energy we needed for that vessel. But on this one, we have designed speed of 25 knots as a top speed, and then we have changed battery technology, aiming to have batteries which are able to have high Cs with regards to the charging and discharging. That means you can recharge them in some 10 minutes of time, and that would be the time when you are boarding and you are in between some stops. Such a kind of vessel is the vessel for the short distance. That means distance up to 20 nautical miles, but I would say not 20, but some 10 to 15 nautical miles. And if we take a look on the Adriatic, it will be in between the islands. It will not be for the further islands we have in the Adriatic, but island connections in between. That will be the perfect ferry. Or it could be the part of the public transportation. In Norway, that would be the fjord connections. On such a vessel, at this moment, with the technology we have at the moment, I would say this is the utmost you can use for the batteries. And then the third concept would be combination of the batteries and the hydrogen. And this is the project idea we are developing at the moment with the University of Zagreb, and it will be our third step. The electric vessels, they are kind of more priced than the normal classical diesel internal combustion vessels, and it's kind of similar like with the cars. So if you're buying the electric car, it's twice the price than the normal car. And here it's very important the message you are sending to the market and to the customers. And I would like to share with you one short movie. And I am sharing that from the car industry, and I hope you will hear the sound of it. If not, at least you will have the picture. Probably didn't get the sound on it. But it's short commercial about the electric car, and basically it's not promoting the electric car. It's saying what would be if everything would run on gas. That means from general home appliances and all the systems. And then this is the market approach. And if you take a look in the past, and you are quoting some of the famous people, then you have the Henry Ford, who said, if I'd asked customer what they wanted, they would have told me a faster horse. Or if you go to the Steve Jobs, he said that people don't know what they want until you show it to them. That's why I never rely on market research. Our task is to read things that are not yet on the page. And I would say the topics we are discussing now, it's right on the same track like those guys in the past. And here I'm finishing my presentation. Thank you very much for the time.
So thank you, Tomo. So I have one quick question. Your boats, what is the average speed that you can have with the small and the big one? And what is the, how to say, maximum distance with the full charger batteries in one direction, what we can expect?
Well, for the small one, the optimal cruising speed would be 5 to 6 knots. It will increase a bit with the technology of the solar cells, and this is going from day to day. They are increasing the energy capacity from the solars. If you increase the speed from 5 to 6 to 9, then consumption raise some 4 times. So I would still stick to the cruising speeds where you have complete autonomy. And autonomy, we said it's 100 nautical miles per day. And with such a speed, that would be the whole day of sailing. So you don't have 50 hours per day in a way that you need more. So this is the optimal size. For that one, we can increase the battery pack. It's not the big one. It's 50 kilowatt hours battery pack on those solar cat vessels. So if you increase it 2 or 3 times, you can increase the speed to 7 and 8 knots. Or if you are not sailing the whole day, you can increase it even to 10, 11 knots. That would be for solar cat. For the iCat vessel, the top speed at the moment is 25 nautical miles, and that one is for half hour of sailing, and then you have to recharge it. Reducing the speed significantly increase the reach of the vessel, the autonomy or nautical miles you can sail through.
So I have 1 or 2 questions from our from our attendees. So first question is, these boats are all plastic material, and the second question is, what is the lifetime of the batteries? So this is very actually interesting, the lifetime of expected lifetime of your batteries, and what is expected from the producer, and what is the situation with live using of these batteries from your experience. So you have experience because you have the data. So
for the lithium ion batteries, I have mentioned at the beginning that we have been calculating the options for the city of Šibenik, where that was the usage of lithium ion batteries on fast boats. And then the producer of the batteries has calculated that the lifetime would be less than a year. And then the same batteries for the application we have right now, and that's this National Park of Mljet, and the low speed is 15 plus years, because charging and discharging is less than 1C, and you are not damaging the batteries at all. So you're kind of taking care of them. And then we have switched to the another type of batteries, and that's the Lto batteries on the another boat. That's because they are able to take up to 7 Cs charging, discharging. But for the lifetime, we have to calculate that one individually. on each case depending on the type of usage. We are always aiming that batteries should last at least 10 years. And then I believe within 10 years, the technology of battery will be improved. And that's something, if you compare the mobile phones, the first one, you have to carry the complete briefcase just for the battery. And now we have the small battery within the phone. And that is my feeling that how the development will go. And if you ask me what kind of batteries and materials, I don't know that, because this is much more scientific research related to such kind of institutions like we have Marine Tech, or we have Ruđer Bošković in Croatia. And for us, we are just kind of system integrator. So we are looking how to optimize the shape and of the vessel, the resistance of the hull, and how to use the utmost solutions on the market. So we are not developing the batteries.
So I have a lot of questions, so I will group them. So first group is linked with the batteries. So which charger is needed at the dock to charge your ship, and how long it takes to fully charge the battery, for example, the first group. And the second group of the question is how the boat deals with the bad weather. And I have also set of questions like how you solve stability in damaged condition, how it's solved. Do you have emergency power genset installed? And what safety solution are used to assure fire safety on board? So I know that you had a lot of experience with registering your boat, so I think that you can give very good answer on these questions. So
before I have started the company, I have been working for the one company in Croatia established by the Norwegian governments, and I was very close with development in Norway. And I know at that point of time, in Norway, the first LNG vessels has been built. And at the beginning, the LNG tanks has been on the rooftop of the vessels. And then over the years, they just move it down in the hulls. Why I'm saying that? Because you have the register of shipping, and those both they are built under the register of shipping, and you are kind of creating or changing some rules together with them. When we applied first time for the new building to the Croatian Register of Shipping, then we got the message from them saying something like sailing with electric boats, it's not defined by the law, and we don't want to approve documentation at all. Then this communication has continued between the Register of Shipping, Ministry of Sea, and us, and we finally managed to pass through to the next step and to approve documentation. And then there was a lot of requirements from the Register of Shipping, and then this is the hard part of the job. You have to convince somebody for whom this is the new technology that the boat will be safe enough. And then you are developing the risk assessment, the classification of space, and the battery testing, and you have to prove it that the safety on the board will be on the required level. So from the battery point, you cannot buy the battery from China, for example. You have to have batteries which are approved by the Register of Shipping. And then the question was about the safety. So we have on this small boat, you have it here. You have seen it on the last slide. The first level is self-extinguishing ampoules, which are all over the engine room and the battery compartment. The batteries are in individual compartment, and in this compartment, no other equipment could be installed. That was the first requirement. Then we have, of course, fire extinguisher all over the board. And then we have the sprinkler station for cooling the space. And we have the fire hose in the case of fire. So talking with my friend who is the the CEO of one Norwegian company in Croatia, he told me this is the most safest boat he ever been on, because everything is about safety. And those are the first steps, and it will be huge requirements from the registered shipping that you have the safety, several safety levels over some time until the technology would be proven in the practice. Then second part of the question was charging and discharging. For this one, all the power you are getting from the solar panels, you can recharge them with short chargers, but we are using the slow chargers on that one. That means if it's a 50 kilowatt hours or 60, we have basically 70 kilowatt hours on the latest one battery pack. You recharge it over the night, and that means some 8 hours. With that one, you are taking care for the batteries. You can do it within 1 hour, and that would be for those kind of batteries to keep them on the long life cycle. Redundancy or security, we don't have any kind of auxiliary propulsion or the diesel generator or anything like that. But the battery packs, they are divided in several of them, and then you have created redundancy. If you have 2 engines, and if you have 2 engine packs, then you can operate each of those engines by any of battery pack, or you can operate both engines with 1 battery pack. So you are creating redundancy with a different kind of batteries. And then you can create different string of the batteries and connect them individually to the to the engines or to the power cabinets. So if one battery goes off or it's out of the service, the other one remains working. Also, we have one requirement from the register shipping, and that is the monitoring system for the batteries. So at the beginning, we have developed the software for online monitoring, and then the next step was okay, the online monitoring is not approved by the register shipping, so you have to have it on board. You have to have complete wired connection and all those security issues registers requiring. And then we have been updating that software with different requirements from the register shipping, and this is ongoing process together with them, as you are doing that as a partner. So they said, okay, we would need to warning signals. For instance, in the car industry, you would get the kind of battery warning, like the battery is empty. You cannot go on. And on the vessels, you cannot get something like the battery is over voltage or over temperature. We are shutting down the battery, because this is not feasible. You don't have the brakes on the boat, so you have to have some kind of pre-warning system. That means sometimes before the batteries will shut down. Fortunately, we never experienced any kind of battery shutting down so far, but the installation for such a vessel is on the higher level. There is lots of communication going through the cables, and then you have the power cables, and you have communication cables, and it's much more of communication on such a vessel than on the normal one. End of last year, I was in one supervisory check of the vessels operating on south of Croatia, and then I have realized that those guys, the perception of how do you have to maintain the boats, it's completely different. So you are not getting the only mechanical guy who is working around with dirty hands and the oil can, but you need some IT guys, because you are programming the engines, you are programming the chargers, the batteries, and then the battery monitoring system. Everything is IT on such a vessel now. And from this point, you have to have clear communication with the customers. That they have to be aware that it's not now a mechanical part anymore. It's much more electrical, and somebody with PC would have to maintain the boat. Charging another boat, the fast boat, I told you that we have speed of 25 knots, and then recharging time could be within 10 minutes. In that case, the charger has to be 2 megawatts. And then for 2 megawatts, you have to have huge power supply, or you have to additional battery set on shore, maybe connected with a solar plant. And this is then developing technology, charging technology, which you have to agree with the final customers. Would they like to invest to additional power source like the solar plant on the shore, which will recharge a battery set on shore, and then you can have fast chargers without connecting to the power network. In Norway, this is, I would say, much easier because you have a lot of electrical energy. In Croatia, the power network is not that strong, and we don't have that much energy. So putting the high power chargers on the electrical grid will cost you much more, because you are paying for the peak power, installed power for the chargers.
So thank you, Tomo. There are few other questions, but I think that will stay after the presentation of others. One is linked also with the hydrogen. So please, see and think what is the difference between batteries and hydrogen, and your opinion of using of hydrogen. Because as I said, you had experience with registering electric. What will be hydrogen? Maybe you heard something, So question after Anders, so we will answer. So thank you very much for interesting a lot of questions. I will write them down and ask after the presentation of Anders to have the discussion. So thank you, Tomo. Anders, floor is your question we had about the hydrogen. So if you have something with the hydrogen in your presentation, of course, but also after your presentation, discussion before starting of webinar about hydrogen, it will be very good to talk after your presentation to answer the question of the attendees. So floor is yours.
Thank you, Boris. So my name is Anders Walland. I'm from a research company in Norway called SINTEF, and a part of it called SINTEF Ocean, which is looking into all kinds of research questions on what's happening below the ocean, in the ocean, and above the ocean. So we're looking both at technical issues for ships. We're looking at technical issues for exploiting oil and gas reserves that Norway has, and also the biomarine harvesting of fish and algae and shells and so on. So we're basically covering everything in the ocean. Now I'm going to talk a little bit about what we call the fuels beyond hydrogen. And we were having a slight discussion prior to this meeting where it was mentioned that, well, struggling with batteries and making electric ships, hydrogen is maybe a way in the future. In Norway, we have been working a lot with electric ships, and while it's not, it's relatively new also in Norway, and most of the issues that was mentioned in the previous presentation is also very much on the table in Norway. In Norway, we are also looking at hydrogen, and it's been presented as a possible future solution. So that's why we want to talk about, okay, is there anything beyond that? And then before I start, I would like to mention when it comes to this, the electrical grid, yes, we have a lot of hydropower in Norway. We have a lot of energy, but we are also struggling with power. So electrical power is an issue, and it's a really big issue. And that is what is going to cost a lot of money when you are electrifying more and more ships. Okay, let's see, I'll get this. There we go. Total CO2 emissions, if you look at global shipping, is about 3% of the global CO2 emissions. This is a curve showing what has been done in the IMO, the International Maritime Organization. They did several studies on CO2 emissions from shipping, and looking all the way back to 1990 and up to 2018. So 4 studies, the second, third, and fourth studies are shown here, and they all tend to agree on the total amount of CO2 emissions from shipping. We have to have a certain image of what is the challenge when it comes to shipping. This is global shipping again, and this is based on the European Maritime Safety Association's figures. So it's about 90,000 ships in a global shipping fleet above 500 gross tons. And the most important part of this image is the one to the right, because it shows what the current fuel mix in global shipping is today. So global shipping consumes approximately 300 million tons of oil equivalents per year. As you know, with COVID and everything, things have changed. But in a normal year, it would be something around 300 million tons of oil equivalents. And this is distributed as 3/4 is heavy fuel oil. And if you look at this small slice of 2%, LNG and others, that's where you find LNG, methanol, LPG, and batteries. And you couldn't show, for instance, batteries in this because it wouldn't basically show in this figure. It's that small yet. The other figure that's quite interesting is if you look at the middle one, you will see that this is then set up as a percentage of which vessels have huge engines. So it basically says that about approximately 30% of the ships in the world use approximately 80% of the fuel. And these are the 30% biggest ships. So that's where we need to really get going if we want to reduce greenhouse gas emissions. Now there are basically 3 types of measures to reduce carbon intensity. You could do something on design and technical improvements of the ship. You could do operational improvements in how you utilize the ships and the capacity of the ships, or you could switch to fuels with either zero or low or very low greenhouse gas footprints, for instance, as batteries. And this is what I will be talking a little bit more about. It's also good to know so what's happening with the International Maritime Organization and ship emissions and climate impacts. So presently they are regulating nitrous oxides and sulfuric oxides. And these are human health and local pollution issues. And they're quite big. Shipping in total globally stands for about 15% of all local air pollution on this planet. 15%. While on climate gas, it's 3%, 2 to 3%. The IMO prohibits deliberate emissions of ozone depleting substances, and it regulates CO2 emissions through the MARPOL Annex 6. And it's also important, I'll get back to this, but the IMO regulations are on what we call a tank to wake basis. So it's the emissions that come from the ship alone. So it's from the fuel that's on the ship, and that's what IMO is looking at. But they are now getting under increased pressure to also include other gases than CO2 into greenhouse gases, for instance, methane and laughing gas, N2O. And they're also under pressure to include what's called a life cycle analysis on the fuels on a well-to-wake basis. That is, from the production of the fuel and all the way until the energy is dissipated through the propeller. So this is quite important. If you look at this figure, it illustrates the difference between what we call the tank-to-wake and the well-to-wake. Looking at tank to wake and CO2 only as IMO does today, and the well to wake looking at CO2 equivalents. In the upper figure, you will see that LNG, for instance, and LNG is a highly debated topic these days. LNG will give you approximately 24 to 25% reduction of greenhouse gas emissions compared to marine gas oil, if you look at the tank to wake and CO2 only perspective. If you include what's known as the well to tank, so the production and distribution emissions for the fuels, you will see that the figures are different. So what we call the dual fuel Otto cycle engine on LNG has approximately a 4% benefit compared to marine gas oil, while in the previous figure it had a 24% benefit. While the dual fuel diesel cycle engine has approximately 16% benefit compared to marine gas oil, if you look at the well to wake, compared to what the IMO is doing today, where it looks like it has a 25% benefit. Switching to fuels with zero or lower greenhouse gas footprints, we can go all the way from conventional fossil fuels. I've already shown you that some of them can actually give lower greenhouse gas footprints. We can look at biofuels, hydrogen, ammonia, and synthetic e-fuels, synthetic fuels, or electric power from batteries charged from the grid. Now, the electric power was covered in the other presentations, so I will not go much into that. But I will try to show you some figures on these conventional fuels and how they can compare to what's going on today. So we're always comparing to marine gas oil, or low sulfur heavy fuel oil. So in these figures, you see the vertical dashed green line is the marine gas oil on a diesel engine. And that's what we call the 100%. So that's the emission basis that we're looking at. If we look at a marine gas oil on a dual fuel Otto cycle engine, it has an increased emission because it uses more fuel. It's less efficient than the diesel engine. This is known. If we look at and we can in this picture, we also look at the different global warming potentials on the left side in a 20-year perspective, and on the right side in a 100-year perspective. So what's the difference? Well, methane, for instance, has a global warming potential which is higher in the 20-year perspective than in a 100-year perspective, because methane has a very short lifetime in the atmosphere. So you release it, and within 10 years, most of it's gone. If you have CO2, the story goes that CO2 has a residence time in the atmosphere of more than 100 years. So it takes more time to dissipate the effects of it. And this figure basically just tells the same story. It's important to understand what is the basis of your comparisons when you are trying to compare and see what kind of benefits do you get from the different types of engines and different fuels. So as you can see from the figures, you get quite different answers if you look at the 20-year potential or the 100-year potential, and if you use different type of engine technologies. I would like to just briefly dip into this engine technology side, because when it comes to the issue of methane slip, there are quite a few misunderstandings about. Methane slip is something that happens when you do not combust all of the methane that goes into the engine as fuel. And this is typical for a Otto cycle engine, where you premix the fuel with air before it enters the cylinder. So the fuel and air is premixed, sucked into the cylinder, and then this combined gas is compressed in the cylinder. And what happens when you do that? When you compress it, it tends to fill every crevice within the cylinder. So it fills up all the volumes between the piston and the cylinder wall, for instance, and it also migrates to the cylinder wall. And now inside the cylinder, while everything is happening fast and combustion is happening, the cylinder wall is relatively cool, and that's where it is hard to combust methane. And in all these crevices, you probably have a less or you have a richer mixture of methane with air, and you cannot combust it. So when the combustion is over, you open the exhaust valve and you expand the gas, then this unburned methane will follow the gas through to the exhaust side. That's what is called methane slip. And that happens typically in Otto cycle engines, and it's relatively unavoidable. You can reduce it quite a lot, either using measures in the exhaust stream, or you can also use measures in the combustion process. But for a diesel cycle dual fuel engine, where you directly inject the fuel into the cylinder after the air has been compressed, and you do not premix air and fuel, you can, in principle, have no methane slip at all. You burn all of the methane. Some of these engines do have methane slip, and that's due to the physical design of the engine, but that can be alleviated. So it's quite important to know this. Jumping into biofuels. Biofuels can be very, very good. And they can still, in this figure, we use the vertical green line, which is the marine gas oil on a diesel engine. 100% is the vertical green dashed line. Biofuels are all over the place. And you probably heard that. Biodiesel from palm oil in this figure shows about a 300% emission compared to marine gas oil on a diesel engine. While if you look at the other end at biogas, or you look at, for instance, biofuels from crops, residues, and waste, you can have a very, very high impact from using biofuels. So with a diesel engine dual fuel on biogas, you can get maybe down to about 20% of the marine gas oil emissions. So 80% saving. That's quite important. But if you do it wrong, you get a lot more CO2 or greenhouse gas emissions. Also with hydrogen and ammonia are just carriers of energy. And ammonia is a carbon-free fuel. It's not an environmentally friendly fuel. It's a toxic and corrosive fuel, but it can be used as a non-carbon fuel. And as this figure shows, if you produce hydrogen or ammonia from renewable electricity, you can get as low as 0%. So you have no emissions at all, not in the production and not in the use. If, however, you look at the situation today where you steam reform hydrogen from natural gas, hydrogen will give you a higher total greenhouse gas emission if you use it today as is. And also if you put in and use electrolysis on the EU mix of electricity, you get very much higher. So you get more than double your total greenhouse gas emissions from using hydrogen or ammonia today as it is. So this is trying to show what is the difference between starting to use it today and what might be in the future if we are able to produce everything from renewable electricity. And that's a question I will get back to a little bit later on. So what about these synthetic e-fuels? E-fuels are fuels that are made from hydrogen, carbon dioxide, and they are blended in a synthesis process and made into a hydrocarbon. So you can design the hydrocarbon. You can make a gas or you can make a liquid. I'll just jump lightly through this one, but it's important also to know that when you're talking about all of these different fuels, people use many ways of describing them. And it's very important to have a consistent comparison methodology. So in our communications, we always consistently label fuels as gray if they are purely from fossil sources. We label them blue if they are from fossil sources, including carbon capture. And we label them green if they are totally renewable, all the way from production to use. And then we use also the orange color to say it's any blend between the gray, blue, and green. And this is an important slide because it shows that if this slide tries to show the amount of energy you put into your fuel compared to the amount of usable energy you get out of it. So for every unit usable energy you get out, this is the relative amount of energy you put into the fuel. So if you compare from our current suite of fossil fuels, I said almost 98% of all fuels used in shipping is fossil based. If you go to hydrogen or ammonia, you double the energy input in order to get the same amount of usable energy out. And if you would like to make the synthetic fuels, you triple the amount of energy in order to get the same amount of usable energy out. There have been a lot of work done on trying to estimate the future cost of these fuels. And if you look at what the fourth IMO greenhouse gas study and the Lloyd's Register and UMass studies has shown, today in the high price estimate, you would see a difference between the current fuels, which we set at 1, see that LNG is about 25% higher, hydrogen and ammonia is 4 times higher cost, and synthetic fuels today about 10 times the cost of very low sulfur oil today. But if you look into the future and you take into account that the main driver of the difference in cost is the energy input, then these figures are 1 for the very low sulfur oil, 2 for hydrogen and ammonia, and 3 for green diesel. So what are the pros and cons then? Hydrogen and ammonia are expensive fuels, and they will always be, because they require a lot of energy input. What is not so much on the table when we're discussing hydrogen and ammonia is that risk levels will increase compared to what we're operating on today. Even when you do the right measures, it will increase. You require new and complex infrastructure on board. You cannot use anything that you already have. You have to have new stuff on board. And you also require everything onshore in production, distribution, and bunkering. Infrastructure has to be brand new. You have to make everything all over again. You have to design the vessels differently because hydrogen has a very low energy content. You cannot gradually introduce this because you cannot blend it with what is already existing. It requires a totally new business model for shipping, and the higher cost is both in the fuel and the infrastructure. If we go the way to synthetic fuels, they are even more expensive than hydrogen and ammonia. As I said, they require 3 times the amount of energy, whereas hydrogen and ammonia requires 2 times the amount of energy. So it's 50% more expensive in terms of energy input. But the risk levels are exactly the same that we have today because you're producing a hydrocarbon that you're using today. It uses the exact same infrastructure on board. You can use the exact same engines, the exact same pumps, tanks, and so on. And also for distribution, production, bunkering on shore, exact same. You don't have to make anything new when it comes to this. So all of these costs disappear. All of the costs that you need in addition to the increased cost of hydrogen and ammonia is now gone if you go to synthetic fuels. You get a higher price for the fuel, but no additional cost. And it can be used on any vessel. It can be used on all existing ships, and it can be gradually blended in to any ship and in any amount. And then finally, I have two more slides, I think. The question here is, these figures show the total amount of energy produced energy that is fossil-based produced in 1990 and in 2018. So it increased from about 8,800 million tons of oil equivalent to about 14,000 million tons of oil equivalents between 1990 and 2018. And what you can say is that coal actually increased its share from 25 to 27%, while oil decreased its share. Natural gas increased its share. And you can see all of the renewables have basically moved just slightly. So the question is then, if we are going to produce everything from renewables and everyone else is going to remove oil, natural gas, and coal with renewables, how are we going to make that happen? And just as an input to discussion and reflection, if you use the if you take the as is today, so this figure says 400 million tons of oil equivalents used by shipping. I said 300 earlier. This figure says 400. It's not always easy to fix the figure, but if we take 400 million tons of oil equivalent used by shipping, if you want to change that to e-fuels, you would have to use 710 million tons of oil equivalent in energy. If you want to, you could take that from renewables. If you do that, you would then reduce the global CO2 emissions by, or greenhouse gas emissions by 3%. If you took the exact same amount of energy and you replaced coal-fired electricity production, you would reduce global greenhouse gas emissions by 20% for the exact same input of energy. And we think that's also an important aspect to keep in the back of your mind when you're looking at what kind of solution you're going to go for in the future. Thank you. That was me.
Okay, thank you, Ander. Very good presentation with a lot of information. One question arises from your presentation. Nowadays, everyone talking about the production of the hydrogen. So people are not familiar what is the difference between green, blue, gray, orange hydrogen. So could you please give some explanation? You had that slide, so it will be very good to show it, because everyone thinks that hydrogen produced from natural gas or from renewable electricity is the hydrogen, but in European legislation is not laid on the same way, so it's not the same. So please, short explanation about hydrogen.
Yeah, this is the one, the slide you were talking about. So basically, it's true. There is no real consistent way of talking about these things. But I think that if you look at the different publications on these issues, people tend to say that if you're talking about gray hydrogen, for instance, it comes from steam reforming of natural gas without any handling of the CO2 emissions that comes from it. So that's a gray hydrogen or ammonia. If you call it blue, that's when you also produce it from steam reforming of natural gas, but you capture the carbon. And it's quite important to know that nobody does that today, but that's a potential way of producing it. So blue is a potential way of producing it. Gray is what is happening today. So gray is the production of hydrogen from steam reforming of natural gas and just letting the CO2 emissions go into the atmosphere. That's what's happening today. Blue is what you could do if you can get the carbon capture and storage going. And then the green labeling is if everything you do starts with renewable energy. So in Norway, for instance, we have hydropower, which is still considered renewable. It has a very, it doesn't have zero greenhouse gas emissions. I think that the current figure is about 12 or 15 grams of CO2 per kilowatt hour from hydro, more or less. But it's very, very close to being zero. Wind energy has about 12, I think, and solar approximately the same, around 10. But that's what we call green. So if it's from renewables, we call it green. And then we have made the orange figure, orange color as well, just to confuse everybody, because it's any blend of the gray, blue, and green. So there are different ways of producing it, and we say that if you are blending from different sources, then it's orange. So I hope that was a little bit clarifying.
Yeah, that orange is also new for me, so I didn't know for orange hydrogen. I heard for blue, green, gray, but
yeah, we made that, so it's maybe it's just confusing, but we see that from time to time that there's a mix of sources for hydrogen and ammonia.
Okay, so one more question. they said there are 100,000 merchant ships on the market. What is
Yeah.
your opinion on the order book of zero-emission ships? How long will it take to replace the fleet with the zero-emission vessels?
Oh, well, I think that first of all, the maritime industry is they're very good at sticking to regulations. So if there are regulations and there are heavy penalties in using call it the wrong type of technology, the maritime industry responds and starts using the right type of technology. So they have shown that time and time again. They have a very good track record. If you put regulations in place, then you get the results. So basically, if everybody just agreed that everything should be, let's say, 50% better in 2030 or 2040, it will happen because the maritime industry is very good at making it happen. Right now, as you say, the number of ships in the global fleet, there are a lot of them. Tomislav was talking about, I don't know if I said your name correctly, so apologies if I didn't, but you were talking about electrical vessels. And if you look at what DNVGL, they keep track of electrical vessels and battery operated vessels in the world. And it's numbering in the few hundreds. I think it's around 400 or maybe 500 ships that have batteries in some form. So some of them are all electric and some of them are hybrids using diesel machinery with batteries, for instance. So if you compare that 400 or 500 ships with batteries on board, for instance, to the 100,000, you get an idea of where we are. We are just starting. And I think it's important to realize that we're just starting. And I think it's important to realize that we need to go slow at the beginning to find these good solutions. So what was presented earlier here is exactly that. It's finding these good solutions. What we're doing in Norway with our fjord crossing ferries is finding the solutions, learning how to do this. And when we've learned it, it's much easier to get to scale it and to know how to scale it efficiently. So it's important that we don't run like headless chickens and try everything all at the same time, because then it will be really hard to change the global fleet. And it's also important to remember that the IMO is still saying a 40% reduction in greenhouse in CO2 emissions by 2030 and a 50% in total greenhouse gas emissions by 2050. They're not talking about 100% reduction. That should happen later on, according to the IMO. So it's important to understand that and see the scale that you need to do. The scale is huge. Scale is really, really huge. But according to the research we do, we see that there are a lot of solutions that you can take right now and implement in new ships that will actually bring us to those different targets that the IMO is setting. So we think that it should be possible to reach those targets by 2030 and 2050. And we know that the maritime industry is very good at responding to actual regulations. But as you also know, the maritime industry is about money. So if no regulations are in place, they will do what is cheapest. And if you put regulations in place, they will follow them. So that's my answer.
Okay, thank you. So there is in the chat discussion about how many orders of new electric ships, but I will ask you the question about hydrogen. We had a short discussion before the start of the webinar. Yeah. Your view on the using of the hydrogen experience. We talk about projects in Norway. Yep. So battery, hydrogen, electric, e-fuels, LNG, your opinion, where and when, how to say?
Yeah, okay. So I think that Norway has basically led the way on battery operated or some battery operated vessels. So we have our fjord crossing ferries, and we are now basically changing most of them into being battery operated. So all of them will be electric, or most of them will be electric. I think there's something like 65 or 70 all-electric ferries on order right now in Norway. If you look at the hybrid operated vessels, there are a lot of different types of hybrids, and some of them can get very, very good solutions and very, very much reduction in fuel use when you do it correctly. And then, of course, we are looking into hydrogen. And right now, there is one project on one ferry that is going to be built for liquid hydrogen, and it's a research project. So it's learning how to do it. It will not lead to any emission cuts. It would actually lead to about 70 to 100% more emissions due to the fact that you don't get green hydrogen today. But it will pave the way to learn more about it. But I think that it's hard to make the argument for hydrogen as a huge energy carrier for the maritime, because of the things that I said in one of these slides, that you actually need to change everything if you do that. Everything needs to change. And the question is, why would we want to do that? If we can make synthetic fuels, and they are still in the research stage, that's true, but everything has been in the research stage at one point or the other, and we need to develop them. But if we develop them, we can get something that goes to zero emissions and uses the infrastructure we have today. And that is important because it uses much, much less resources than if you start using hydrogen and ammonia as it is.
Yeah. That's the. It's we have very short goal. A deadline is very short, and we are still how to say playing between different technologies.
Yes. But it's important that even though there is a short deadline and you might feel a little bit stressed about it, it's important to, as we say in Norway, breathe with the stomach. It's like take a deep breath and sit down and think about the problem and how to solve it, and not just try to solve it in panic, but try to really think about how to get the good solution and then how to scale it. That's the important thing. So,
and one question, what about it's a very good question. So they say it's they're looking for cheaper solution to reduce the emissions. They are ordering new ships with scrubbers and things like that. So what is status with that? What's your opinion? Is going to reduce enough, or is just to, how to say, stay alive until the next deadline? So
well, that's an interesting question, of course. Scrubbers are being installed to meet the sulfur oxide requirements. And if you go a couple of years back, it was a quite good solution in economic terms, because the price difference between the very low sulfur fuel oil and the heavy fuel oil was quite big, so you could play in that gap. Now it turns out, after the regulations were put into force last year, the very low sulfur fuel oil turns out to be not so expensive after all. So the question is then, are you really saving anything by going for the scrubber solution? And the scrubber solution increases your energy use by a couple of percent. So it basically increases your greenhouse gas emissions. But the more interesting question is, so what happens if you can capture CO2 on board your ship? So if you can have carbon capture on board your ship, together with a scrubber solution for the sulfur oxide, maybe you then can reduce your greenhouse gas emissions, run on cheap heavy fuel oil, and remove the sulfur emissions as well. Maybe that's a cheaper solution overall.
Oh, okay. So that was the question. What are the solutions? CCS was the question.
CCS is one of the things we are actually we are starting a project right now where we're looking at carbon capture on board. and technologies that are suitable for carbon capture on board. So the carbon capture industry has been land-based so far. They have a lot of space, and doesn't matter how much it weighs and how big it is. On board the ship, of course, it does matter how much it weighs and how big it is, and it's really huge as it is right now. So there needs to be quite a lot of development in reducing the size, making it more compact, more efficient, and so on. And that's what we're going to look into. But if you can find a solution there, you can still operate on cheap oils, and maybe it's also good that we could burn this residual oil.
Okay, so thank you very much. A lot of questions, a lot of very good answers. I think only one additional question to Tomislav regarding the hydrogen and electricity. Anders, thank you very much. So Tomislav, if you are here, your opinion, hydrogen, electricity on board, on the ship vessels, especially the short routes, how to say, and your experience, in your experience, what will happen if you go with the hydrogen and registering your ship? You had a lot of problems with electricity. What will be with the hydrogen? How to say?
Well, it will be the same. We have been discussing the hydrogen some 10 years for the city of Šibenik in Croatia, because at that point of time the batteries technology wasn't at place. So we have been discussing with the city of Šibenik if it's possible to try to do something with hydrogen. And then city of Šibenik told us we don't want to go to hydrogen at this point, because at the moment some journalists will start to write about the pressure tank of 700 or 900 bars. The newspaper will start to write about that you are carrying around the bombs with yourself. So this is something I would say, like Anders told before, it has to go slow steps, and you have to learn the public that this is not that that the safety is on the place, and it's not that dangerous as it is. So sympathizing with the public over the time, yeah, it's crucial. When you're comparing hydrogen batteries, I would say batteries for the short routes and the hydrogen for the longer one. Longer run, I don't think that we are at the point for the ocean sailing. It's still without the domestic waters or neighboring countries. And using the batteries is kind of silent type of usage. Hydrogen you can use with combustion engines, or you can use it with the fuel cells, and it's up to the technology. And if you are getting back with hydrogen to combustion engines, I would say this is not the direction you should go. It should go to the fuel cells. Then this is the ecological part, but then it's also the part of the noise, vibration. It's different kind of feeling. You know how it's in electric cars comparing to the plastic one. So the feeling you have on board, or the value of commodity, it's on the high level when you are sailing silent vessel.
Okay, thank you very much. And there is one question. Are you not afraid that your innovation will be taken over by shipyards in China? And will it be possible to maintain ZEV production in European shipyards? Will orders be placed in Chinese shipyards? So that is one last question, and one question will be go for on there. So Tom, your answer on this. You are protecting your idea?
No. I have learned from the Norwegians that intellectual property is for the pharmaceutical industry or something like that, where you have to protect cheap product with a high margin on it. But in technology, you just have to develop fast. And at the point when they are copying you, you are developing something new and you're going further. That's my feeling how it should be. There is one great professor in Croatia. He told once to me that these days you can find any kind of patent globally. There's lots of patent search. You have Google patent search, but you will never find who is using your patent easily. So you have to have the army of lawyers all over the world. So patenting, it's not something I'm foreseeing as a future of technology protection.
Okay. And thank you, Tomo. And Anders, last question for you. Where will be stored CO2 captured on the board?
Yes, when you capture it on board, you would have to store it in liquefied form. Some people are also talking about storing it in solid form, but you will have to store it in a tank. So that's part of. You probably need to take away one of your cargo tanks, or you need some space to store it. And it will be in liquid form, so you need a pressure vessel in order to contain it, and also an insulated pressure vessel in order to contain it. So yes, there are a lot of questions that need to be solved, and we need to figure out how to do it. But you know, the question really is, how expensive do the politicians want these things to be? So if they just put a lot of taxes on the fossil alternatives, then you get the price differential that you can play with. And that's where we need to figure out how to do this, and how it's not cheap, but how low can you go when it comes to price for these different solutions? That's what we need to figure out, and that's what we are doing in R&D. And as to I think Tomislav gave a very good question or answer to this question of the Chinese taking over the market. I mean, when you're talking about what we call high technology or advanced solutions, that's where you have an advantage and an edge. Once this becomes mainstream, it's really, really hard to keep it away from the cheaper labor. But as long as it requires competence and high competence, you have the edge.
Okay. So more or less we are finished, answered on all questions. So what about the status in China regarding electric and e-fuels, and do they have any research, any like pilots? Did they build something, Tomo or Anders? Do you know something about what is happening in China? Because you know, China, South Korea, they are the biggest player in this field. So
I could try to answer a little bit. We know that they are moving quite rapidly on LNG, so liquefied natural gas and solutions when it comes to shipping. So they have been doing quite a lot with regard to that. When it comes to batteries and so on, I really don't know the status. And also when it comes to hydrogen, I'm not familiar with any Chinese initiatives on that, but it might be much more on the automotive side that they're moving.
Yeah, me neither. I don't know about the electric vessels from China at all. So the most electric vessels, they come from Norway. That's my feeling. And then you have some small scale electric vessels, but they are actually not electric vessels. They are the electric yachts. So the small vessels up to 10 meters, and they call it the electric vessels. That's something you will find all over the world. Small scale, without any kind of sustainability or the autonomy. It's just like prototyping on small scale. That's what I know.
I see that there's a statement in one of the or in the chat saying that solar panels and batteries are Chinese made. I think it's quite important to know that while a lot of electric vehicle batteries are made in China, batteries for ships are very different. You cannot use car batteries on board ships. They will just they will die quickly. So you have to use a very different type of technology. because ships have a very, very different operational profile than a car does. So yes, they're producing a lot, but currently there are the ones that are making electric or batteries for ships are European, and they're using cells from Asia. That's true, but putting them together and making them into something that can be used on board ships, that's European.
Okay, so we have here a link in the chat about the world first all-electric cargo ship from China. So
okay,
yeah,
sure.
they're working, and that's true with the batteries. They are not the same with in the case of the vessels and in the case of the cars, and especially when you look for the capacity, fast charging of those batteries. Toma, you mentioned something with having batteries on the mainland. So I have opportunity to discuss with Danfoss, and they implemented something in Norway with batteries on the islands, and the ship when arrive charged from those batteries, not directly from the grid, in order to have the stability. So, and they need a lot of energy in a very, very quick time. So batteries need to have resistance, need to stay alive, how to say, because you have a lot of charging, discharging, but very quick and very, very strong charging, how to say. So thank you very much for this. We had 2 presentations, but 1.5 hours. I think it's enough. With a lot of questions, actually, we had like a discussion panel, not a presentation. So thank you all for to our attendees, to our panelists. Very good presentation. So we saw a different technology, different approach. In the future, we are also expecting to create additional webinars with this topic, with this problematic, and about how to register your ship, what are the problems, and we are looking for topics which are very interesting in this field, actually, because the field is very new, and I know that a lot of people, a lot of companies working, but we don't see the final products on the market. At the moment, everything is on the small scale, and the big projects are basically on the testing and on the pilot scale. So thank you all. Thank you, Toma. Thank you, Anders. It was very good, and I hope that attendees have heard a lot of good things. So at the end, we will send presentation to all attendees to see what is happening. Also, the webinar is recorded. It will be on YouTube, and everyone will receive like some small questionnaire after the ending of the webinar to help us to see what is the situation with the research and in this field. So thank you all, and bye-bye.
Thank you. Bye.
Bye.
Bye-bye.